So we're going to take a look at another equilibrium supplementary problem, this time question number 48. It is a Le Chatelier's principle problem, so it's a non-mathematical question, but will involve some explanations. We're given a balanced chemical equation, SO3 gas, sulfur trioxide, is decomposing into SO2 gas and oxygen gas. The first thing I noticed when in that equation that everything is in the gas phase, which is nice. There's no solids, there's no liquids that I have to worry about. I remember from equilibrium, from our notes, that Le Chatelier's principle, solids and liquids, when they're added or removed from a system, do not cause a shift to occur. The reaction shows heat on the left side of the equation. That means that this reaction was endothermic. Okay, when heat is written on the left side of an equation, that means heat is being absorbed. It's endothermic. If heat were written as a product on the right side of the equation, it would mean heat is being produced by the reaction, and it would be exothermic. We remember also that an endothermic reaction has a positive delta H. Okay, the question could have said the reaction is endothermic, or it could have said delta H is positive, instead of giving us the word heat like this in the equation, and then we would have written the word heat on the left side, given either the statement that the reaction is endothermic or that delta H is positive. So we're being asked to explain what will happen to the amount of oxygen in the vessel if, and we glance down and there's a variety of stresses that are being applied to the system. So I'm going to put a box around the O2. This is what we're focusing on. What will happen to the amount of oxygen in the vessel? I notice that oxygen's on the right side of my equation. So if the reaction were to shift in the forward direction, if the reaction shifts to the right, then we're going to get more O2. If the reaction shifts in the reverse direction, then we're going to get less O2. Okay, since O2 is on the right-hand side of the equation, it's a product in the forward direction, so shifting forward produces more O2. If the reaction shifted in reverse direction, the O2 would be a reactant in the reverse reaction, and so reactants disappear over time. There'd be less O2 in a reverse shift. So in each of these situations down below, our job is to figure out whether the equilibrium shifts in the forward direction, the reverse direction, or perhaps not at all. And based on that, we will have to say what will happen to the amount of oxygen in the container. So let's do this first. And remember, we're applying Le Chatelier's principle, which said that a system at equilibrium will shift either forwards or reverse in response to a stress that's been added as it tries to reduce or relieve that stress. So the first stress that's being added is SO3. We're adding some extra SO3. Now, I'll just reiterate here that the SO3 is a gas, so that means adding some SO3 is going to cause a stress. So my answer to this would be that the system will try to use up the extra SO3 that's been added. Now the SO3 is in the left side of the equation, so it's a reactant in the forward direction. It's a product in the reverse direction. If the system is trying to use up this extra SO3 that I've added, then the system is going to shift in the forwards direction. Okay, in the forward direction, the SO3 would be a reactant and would disappear. And shifting forwards means, as we said above, we're going to get more O2 produced. So there's the answer to the question.